All right, in this next lesson, Geometry Angle Theorems, Part 3, we're going to talk about what do you do for any size polygon. So far, we only did a triangle, which we know has 180, and we did a quadrilateral, which means it has 4 sides, which is 360 degrees. So those are the two that we know, and hopefully, as we move into grade 10, have memorized. But what happens as you add more sides? Well, as you add more sides, the shape tends to open up. Think about a triangle, right? Here's a triangle, then a 4-sided, then a 5-sided. See how the angles are getting wider and wider the more sides you add, right? Well, it so happens that every time you add a side, the interior angle sum, which is how much all the interior inside angles add up to, will increase by 180 degrees. So all we're really doing is adding 180 each time. Well, add another 180, right? And just keep adding 180. And that's how you can find it. So if we take 360 and add 180, we get 540 degrees. So all the angles inside will add up to 540. Now that doesn't mean they're all the same, right? Just like our triangle. That doesn't mean they all have to be the same. It just means when you add up all 3 of these angles or all 4 of these angles, the sum will always be that total. All right, and then, 6 angles, add another 180. Which gives us 720 degrees, and so on and so forth, right? Okay, but what if, we don't want to have to keep doing this, like for 7 angles, and 8 angles, and 9 angles. Like, what if we want to know 10 without sitting there with our calculator constantly adding 180? Or what if we get, like, a shape with 120 angles, or 120 sides, 120 angles, right? It's really repetitive to have to sit there and calculate that. So there's a formula for this, and this is basically the formula. I'm going to use A for the angle sum. So I'm going to call that's going to be my sum of my angles, okay? We can use whatever letter we want. I'm just going to use that because that makes the most sense, although A is generally used for area, so maybe it's a little confusing there, right? All right, what you have to do is there's a pattern, right? If we're increasing by 180 each time, here's the secret. All we have to do is if you take the number of sides and you subtract 2 from it, so like 3 minus 2, 4 minus 2, 5 minus 2. If you subtract 2 from that number, what will we get? And 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 2 is 3. And if you take that and times it by 180, you will get that number. So 2 times 180, 1 times 180 is 180. 2 times 180 is 360. 3 times 180 is 540. So that's the formula. The formula is take the number of sides, and generally we write like this. So I'm going to use n for the number of sides, subtract 2 from it. Okay, so that's my number of sides or number of angles. It's the same. If you have a 3-sided shape, you have 3 interior angles, and so on and so forth. So number of angles or number of sides, whatever you want to say, subtract 2 from that number and times it by 180. And that's it. That's the pattern, okay? So there isn't really anything else to it. And really, this is the last formula we need for this unit. So for the last one here that we have at the bottom, we want to know how much do we have for 10, right? Well, here's all I do, okay? If I want to know for 10, I would say, all right, what's 180 times 10 minus 2? So what's 180 times 8? All right, and then let me just grab a calculator here and see what we get, right? 180 degrees times 8 gives us 1440. All right, 1440 degrees. And don't forget your little degree symbol, that little circle up there. All right, so that's essentially the formula we need. We need this formula. It's really important. Make sure you get it down in your notes, okay? This is the final formula you got to know for this unit, okay? Yeah, that's it. So let's do a few more examples here showing how you can use it, okay? And let's do that. All right, so we're going to do a few examples. First example here is essentially the exact same thing. So we want to find out the sum of the interior angles, which means the inside angles of a polygon that has 23 sides. I'm not even going to bother trying to draw that, right? Like, it would be so many sides to draw. So here we go. All we got to do is do what's 180 degrees times the number of sides, subtract 2 from that number, and that'll tell us exactly what it's going to be. So what's 180 times 21? All right, so let's bring up our calculator. What is 180 degrees times 21? What do we got? 3,780 degrees. 3,780 degrees. All right, pretty easy, right? In that case, we're replacing the n in the formula here, right? Replacing the n, the number of sides or number of angles. In the next case, though, it's different. Determine the number of sides. So we're working backwards. How many sides should it have, right? So we're basically looking for the n here, right? N is our number of sides or number of angles, okay? If we already know the sum. So what in this case, we have to replace the a with that. So if I'm going to write this here, let me write the formula down here. All right, so in this case, we have to replace the A, because we know the total. A is going to represent our angle sum. So 5,400 degrees equals 180 times the number of sides minus 2. All right, so let's just use our basic solving skills that we've learned this year. We're going to isolate the n. Well, what's the first thing? Remember, how do we do this? What's the first thing happening to the n? The first thing is you're taking n and you're subtracting it by 2, right? So when we're doing this, we ask ourselves, what are we trying to isolate? We're trying to isolate n. What's the first thing happening to it? Subtract 2, right? So I'm going to write that down here. Step 1, you're subtracting 2. What's the second thing that's happened to n? Well, after you subtract 2, bed mass, what would you do? You'd multiply by the 180 out front, right? Multiply by 180. Well, to isolate the n, we have to reverse these steps in reverse order, right? So to reverse this, what's the reverse of multiplying by 180? We're going to divide by 180, right? So let's divide both sides by 180. So when we do that, the 180 and 180 cancel out. Let's get our calculator and go, all right, what's 5,400 divided by 180? And we get 30. Okay, so we've got 30 sides so far equals n minus 2, right? Now, again, what's the opposite? Working backwards, right? We're reversing these steps. Instead of subtracting 2, the opposite would be to add 2. So let's add 2 to the 30, right? That's how we're going to get rid of this minus 2 from this side. We're just going to go plus 2 on both sides. And there you go. You have 32 sides, right? So therefore, we have 32 sides. There you go. All right, so basically there's only 2 things you can really do with this formula. Work forwards or work backwards, right? Do you have the number of sides and you want to find the total of angle sum, or do you have the angle sum and you want to find the number of sides? All right, let's do a couple more examples here. Okay, our next example says Derek is building a deck for his summer job in the shape of a regular octagon. All right, so we need to identify what does the word regular mean. So let's define regular. In geometric figures and shapes, regular means that all the sides are the same length. Okay, let me get that down. All sides same length. Okay, and all angles are the same size. All right, so if you're talking about a regular triangle, think about it. What's a regular triangle? A regular triangle is called an equilateral, right? An equilateral is a regular triangle. Equilateral, right? And each angle inside is 60 degrees, 60, 60, 60. When you think about a regular four-sided shape, right, what would that be? It would be a square, right? Because, you know, they're all the same length. And what would each angle be? They'd each be 90, right? All 4 corners would be 90, which would add up to 360. All right, so now we've got a regular octagon, 8 sides, right? So what are we going to do? We need to determine the measure of the interior angles of the deck. So we use our formula, 180 times the number of sides minus 2. Well, how many sides does it have? It has 8, right? So let's go, what's 180 times 6? So let me just grab my calculator here and get this moved over. All right, so 180 times 6, boom, boom, boom. All right, so that's going to be 1,080 degrees. Now that's how much they all add up to. Now, since it's regular, every angle is the same size. So what I can do is I can take that 1,080, and only because I know they're the same, right? Usually they'd be marked with hash marks like this, right? That's generally how we know in a diagram, because not every diagram is going to have a word description. But if there's those hash marks on it, we know they're all the same, which means all the angles are the same. And we're just going to divide that by how many angles there are. There's 8 of them, right? So let's get our calculator back up here. And let's divide that by 8 angles. Pretty easy, right? Boom. There you go. Every angle is 135 degrees. All right. So pretty simple stuff. Let's just do one more. A loonie, right? A loonie is has 11 sides on it. It's called an endecagon. Determine the sum of the interior angles of the loonie. Same thing, right? All right. So we got. Oops. Hang on, get my pen working here. 180 degrees, right? Times 11 sides minus 2. So we got to say what's 180 times 9. Let's get our calculator back up here. What's 180 times 9? I got 1,620 degrees. Okay, 1,620. All right, now, if we want to know what each one is individually, we're going to divide that by 11. All right, so let's see what we got. Now, the only reason I'm doing one more of these is because, where's my divide button? Divided by 11, there we go. You can get a decimal, right? 147.27 repeating. All right, so let me just get back to this. 147.27 repeating. So I just wanted to do one more because, yes, you can do a fraction of, oops, I'm just going to put a bar over that since it's repeating. There we go. a fraction of an angle, right? A decimal of an angle. So I just want to do one of those real quick. All right, I just got a few more examples to show you, and that'll be the end of this lesson. Okay, so I've got this one marked with hash marks. I forgot to mark some of them with hash marks. We'll fix that up as we go. All right, showing that they're all the same size. So how many sides or angles do we have? 1, 2, 3, 4, 5, 6, 7, right? We want to know what x is. What's this angle here, right? So what are we going to do? 180 degrees, right? Our angle sum is going to be 180 times 7 minus 2, right? So let's start with that. Let's get our calculator up again, all right, and do 180 degrees times 5, right? That's 7 minus 2 gives us 900. Okay, so we've got 900 degrees here. Now, all we got to do is, once again, let's take that 900 and divide it evenly among the 7 angles, all right? And again, we might get a decimal here, right? Divided by 7, boom, 128.57 approximately. All right, put a little dot above my equal sign, 100, what did we say, 128.57? Yep. All right, pretty easy, right? All right, so this next one, I didn't put the hash marks on. I should have, you know, but let's just say I'll put double ones to show. Okay, these are all the same length, right? Here, 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 here. All right, now the y is on the outside, so we're going to need to use one of our other rules in a bit. But first, let's find the angle on the inside, right? So how many sides does this have? It looks like it has 6 sides, right? So 180 degrees times 6 minus 2, so 180 times 4. Crack out your calculator. What's 180 times 4? We got 720. And you know what? Let's divide that right away by 6 and see what we get here. All right, so we got 120 degrees for each of them. So this was 720. And then 720 divided by 6 angles, right? Gave us 120 for each angle. So every one of these corners is 120, right? All of them are. Now I'm just particularly interested in this corner right here. There we go. Now, how am I going to find that angle on the outside? Remember our rule from before? It was called supplementary angles. It's the half circle rule, right? This half circle has to make 180 degrees. So to figure out what y is just 180, subtract the 120, and y would be 60 degrees. Not too hard, right? All right, let's move on with a couple more here. I'm going to skip 3 because it's really the exact same thing as 2. I'm not sure why I was on here, but this next one is the one after. It's a little more interesting. You can do this one a couple different ways. So you can do what we just did before, right? So how many sides we got here? I'm just marking them off here. So I got 1, 2, 3, 4, 5, 6, 7, 8, I think. Yeah, 8 sides. All right, so let's do our formula again. The total area, or sorry, area. See, I'm falling for it. I wrote A. The total angle sum is 180 times the number of sides minus 2, so 8 minus 2. So we want our calculator and go, what's 180 times 6? Right? Oops. Times 6. We got 10,080. And let's divide that by 8 angles. All right, so 135. So long story short, I'm not going to write all the steps out for this one. I want to keep it moving because I'm sure I'm losing some of you. Each of these angles is 135 degrees, right? Well, let's use the same trick we just used before. Right? How can I find that? Well, again, it's a half circle. So what we're going to do is go, all right, what's 180 minus 135, right? And that's going to give us 45 degrees. Okay, so each of these exterior angles is 45. Well, how many of them do we have? We have 8 of them, right? They're all the same. So what are we going to do? What is, there we go, what's 45 times 8 angles? 45 times 8 is 360. All right, so let me just write that down. I took the 45 degrees, I timed it by 8 angles, I got 360. Now, this shouldn't be a big surprise to some of you if you remember from our first video here on angles. We talked about the windmill pattern. Remember this windmill pattern? So with the windmill pattern, right, all of these angles here, 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 they all have to add up to 360. So what I could have done, slightly quicker way for a question like this, is I could have just done this. I could have just gone, hey, what's 360 divided by 8, right? Divided by the 8 angles, what are we going to get? Each one's 45 degrees. So there's multiple ways of getting at each of these. So that's going to bring me back over to this question. This is a windmill also, isn't it? But it just doesn't have all the sticks on it, right? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Instead of doing it the way where I find the interior angle sum, I could just instead go, what's 360 degrees? Because every one of these windmill patterns has that same thing, divided by 9 angles, and I could find it really quickly that way. So I'm just doing this to show you, you could do it a quicker way with some of these things. 40. So it looks like each of these angles is going to be 40 degrees. So slightly quicker. It doesn't work for every question, but it does work for these windmill pattern ones, right? All right, let's check out a few more, and then we're done. All right, number 5 is a repeater again, too. This is just the one, remember, where this was kind of like going to be part of your homework if you had been in class. That's why some of these are kind of repeats of what I've already taught you. But remember, just one more time, 180 times the number of sides minus 2. In this case, they're telling us that the sum is 9,360. So that's what goes there, right? And then we need to solve for n, which is the number of sides or number of angles. So how do we do that? You take the 9,360, we're going to divide it by 180, and then we're going to add 2. And that's going to give us n, right? So what are we going to get? Let's do that in our calculator real quick. 9,000, let me move this over a bit. 9,360 divided by 180. There you go. Add 2 to that, right? And what you end up with is 54 sides. And 54 sides, 54 angles. Okay? There you go. Now, this last one's a favorite of mine. This one is supposed to have some hash marks here. This was on an EQAO test like a decade ago, and it just caused everyone mass hysteria, panic. There was no numbers on it. No one could figure it out. It drove everyone nuts, right? Well, let me show you. Let's zero in on the inside here because it had no numbers. No one knew what to do. Look at this. We got a 5-sided shape there, right? Well, 5 sides, let's use our formula. So 180 times 5 minus 2. So what's 180 times 3? All right, so 180 times 3, right? Boom, we got 540 degrees, okay? So that's what the sum is. All right, now let's divide that by the 5 angles. So let's take that and divide it by 5. And what do we end up with? 108. So if I take this and I divide it by 5, each angle is 108 degrees. So 108, 108, 108, 108, 108. So we're going to put together what we've done already. These two corners are 108. They all are, right? I guess I can write them all, and it just gets a little redundant. Now, remember our semicircle, half circle rule called supplementary angles? We can draw a half circle in here, and each of these would be 180. If we subtract the 108 from those, what are we going to get? 72, I think? Yeah, so this is 72, and this would also be 72. Well, guess what shape you got at the top? You have a triangle, right? A triangle has 180 degrees in it. So what's 180 minus 72 minus another 72, and you end up with 36 degrees is what W is right there. So sometimes we can have no numbers on these things, right? Just like the ones we saw before, these ones we were doing. There's no numbers on them, and that's where we want to start. All right, I just want to look for one more question with you here. All right, here's another one that we have to use this rule for. Let's start. This one really threw people off on the test last year. But let's look at the top. There's two kind of shapes just stuck together, right? You got this shape up here. So let's focus on this one first that I'm highlighting in yellow. It's got 4 sides, right? So it doesn't have to be a square. As long as it has 4 sides, it's a quadrilateral. All right, so how many degrees are in a 4-sided shape? 360, right? So we know there's 360 degrees in here. Why don't we subtract the 60 and subtract the 115 and see what we get? All right, so we have 360 minus 60. It's going to give us 300, right? And then minus 115, and we end up with 185 degrees. So there's 185 degrees for the other 2 angles, right? Now, both of them are labeled with a y, which means they both have to be the same thing. So to figure out what they are, all I have to do is take that and divide it by 2. So y equals 185 cut in half, right? Divided by 2. And what are we going to get? Let's pull up our calculator, right? Divide that by 2. Divided by 2. 92.5 degrees. There you go. Pretty easy, that top part, when you see it done, right? So this is 92.5, and this is 92.5. Now, what about the bottom shape? How many sides does it have? Well, let's highlight and check it out here. 1, 2, 3, 4, 5, 6, 7 sides, right? This I don't know off the top of my head. So this is where I would use my formula that we learned in this lesson. So we have 180 times 7 minus 2. So what's 180 times 5? Pull up my calculator for that. 180 degrees times 5. It's going to have 900 degrees in it, right? Now, to figure out what x is, we know pretty much all the other angles. We know 1, 2, 3, 4, 5. We don't know x, which would be 6, and we also don't know this angle here. But here's the trick to finding that angle. This makes 360, right? That's a full circle. So what's 360 minus that 115 degrees? All right, so let's grab our calculator, see what we got. 360 minus 115, 245 degrees. So this angle on the inside here, right? Let me get rid of this here. This angle right here is 245 degrees. All right, so now if we know 6 of the angles, we can easily find the 7th. All we have to do is just take that 900 degrees, subtract all the other angles, right? Subtract the 120, 130, 135, 140, 50, and 245. I'll pause and punch in the calculator to spare you the pain. And when I subtracted all of those, I got 80, I believe, for x. So there you go. X is 80 degrees. That's what's left over. Pretty easy, right? So again, you're going to have to use that formula. That's what you need this for. And notice there really wasn't much interaction between the top and the bottom other than that circle right there in the middle. All right, so I think that's enough for this lesson for you to try some homework questions on it. Give it a go, and don't be afraid to ask questions if you have some.